about how to do welding analysis using Python code to draw a profile, extract the area, inertia, section modulus, tensile shear, bending, and equivalent stresses. So this is how I wrote the code, and I will discuss this with you. First, I will go to theory. So I will go to draw this one. Suppose I have rectangle profile. Sorry for my drawing. And this is the weld area which I want to calculate the stresses. So this is my weld area over here. This is my x direction. This is my y direction. And this perpendicular to this, it is my z direction. So now I want to calculate this. So first is shears. I will calculate the tensile stress, shear stress along the x and y direction, tensile stress along the z direction, and the bending moment of all of this. So I will calculate my IY, IXX, IYY, IZZ, and section modulus of all three directions. So this is my strategy. Now I will execute into Python. How I will execute the Python. So first I had created the dictionary. I had created dictionary because I'll let you know. So force is equal to Fx is equal to 1 e raised to 5, Fy is equal to 1 e raised to 5, Fz equal to 1 e raised to 5. The moment I same created the dictionary, input width is like 100, input height is like 200, throat thickness of this weld is 5 millimeter. Now the calculation of property of square weld profile, it is like I created that function. I will explain you, but the input of that function is input width, input height, and throat thickness. Now I'll go to this function that will calculate the property of the square weld profile. So first I had to calculate the area. So as you know, I will not go into detail. It is like weld structure. I had calculated IXX, IYY, IZZ, same as WX, WY, and WZ. If you see here, I again created one dictionary called, it will store the area is equal to area inertia into IXX, IYY, IZZ, and section modulus WX, WY, WZ. So I had created this dictionary because when I used to in this Python function call into another file, so it will be like very helpful for me. That's why I created the inertia means this dictionary. So in dictionary, area is equal to this area, inertia is equal to this value, and section modulus is Wx, Wy, and Wz. Now I got my area. So property, how I call this area function. So property, it contain area, right? So area is equal to property contain area. I can directly just created what to say, just area is equal to here. I can write the code and it is fine for me. But this is for one code. If I want to use like this function in every other code, so I cannot call every time I wrote like this line. So I will at the time I will just write calculate width, height, and throat thickness. That's it. So for future easiness, I had created like this function. Same with this directory, uh, dictionary. Sorry. So property, it contain area. So it will look out the area and it will assign that value to this area property. Same with the inertia, but inertia contain all the property IXX, IYY, IZZ. If I want to extract that property, I have to inertia dot y. So that how I want to. Same with the section modulus. Here I had print all the section modulus property. So here I use f this curly bracket it is for calling the function. So I had called the function area. If you see here, area, that underscore dot 2f. That dot 2f means it will call the print the two decimal in floating way, and this is the square. So again, it will print. If I open this file, you can see here how it is printed. So wait, I will stop this. So you can see here how it is printed. So it is like 1.73 raised to meter cube, how it is printed. So this is inertia ixx, iyy, izz, same with this. So now I'll go with the stresses. So stresses is, I will include the forces, this directory, moment directory, area, inertia, and section modulus. So this is my requirement for stress calculation, right? So I'll go to stress calculation, which is again force, moment, area, inertia, and section modulus. Inertia I don't need. Why? Because I already have section modulus. So m by z, it will not create inertia, but I kept it as like future need. If I need any property which is help me, I'll just kept it here. So fx is equal to, as I mentioned you, fx is equal to force. So this is the how you call the directory. The force, so force here, fx, it will look out fx and it will assign the value of the fx. Same with fy, fz, same with mx, my, and wx, wy. So tensile stress is fz upon area, shear stress is mx and my, square root of this area, and same with the bending stress is mx upon wx, bending y is my upon wy, bending stress z is equal to mz upon wz. So now I will combine the stresses. So bending stress is equal to under root x direction square, y direction square, and this is the z direction square, right? So this is same with this, and the equivalent stress is like equivalent stress or combined stress is equal to under root or sqrt, tensile stress square, bending stress square, and 3 times of shear stress square. So it will give me equivalent stress, and the returned value of this is like tensile stress is equal to tensile stress, shear stress. Again, I created that directory for easy use. Now I'll print those my stresses. So for stress types, in stress value, in stress item. So this is the stresses. It will contain item, right? So it have two item. One is the stress type, which is like this one, tensile stress, and this is the value, right? So for I use the for loop and print the value of f. Again, the stress type is here, and the value is again 2f and MPa. This is the thing. Now I want to visualize my how the diagram is, my profile is look like, right? So visualize profile, I again created the function for that, and the input width, input height, and the throw thickness for my visualization of the square profile. So when I go to this define input, so this is the my size of the figure 6 by 6. Now plot. So this is the thing where how I did. I will show you. So I did like first it is start with this. So I assign this point, then this line I assign this point, same with this point, same with this point, and I close the loop and I assign for this. So this is like minus w means width divided by 2, and this is height divided again all the minus height divided by 2. If I want to center it at 0 0, same with this is like w by 2, this is minus h by 2, and this is the again w by 2 means width by 2, and this is the h by 2. Same with this one, minus yes, minus W by 2, and this is the H by 2. And fifth, again to close this loop, I again wrote this one. So if I go here, if you see here, this is first my x-axis. So this is my x-axis, and this is my y-axis. This is my y-axis, and the R means red with single line width is 3, and label as the field. Same with the plt.fill. So what it will do, it will fill my full uh, like simple blue or simple red color. So how it will, again it is the same plt.fill, and you have to mention the what is the color here and what is the diffusivity value. 0 means it will like opaque like glass, and 1 means it doesn't have any opacity. So this is the alpha value. Same with I title, I have a square profile, width is like this one in mm, height is like this mm. If you want to create function into double inverted comma, you have to write in curly bracket. So this is the thing which I had used. Same with X label, width is mm, Y label is height is mm, grid is true, legend is true, axis is equal, and PLT show means it will show our thing. So when I run this code, so it will run this, it will show me like this way. So if you see here, my weld profile is like 5 millimeter, my profile is like 100, this minus 50 to this 50 means 100, and this is 200. So this how I wrote the code. If you have any question, any doubt, please let me know.